going to talk about the action of aldehydes and ketones with certain ammonia derivatives. What are called ammonia derivatives? We know that this is the ammonia NH3 in which one of the hydrogen is replaced by OH group. So it's a derivative obtained from the ammonia. The name of the derivative is hydroxylamine. Likewise, the other one, NH2, one of the hydrogen is replaced by NH2. This is to be called hydrazine. And the third one, NH2, NH in which one of the hydrogen is replaced by phenyl. So that you can call this as phenylhydrazine. And another case, NH2, NH, C double bond O NH2. Actually, this is a derivative of ammonia where the hydrogen is replaced by this particular group. You know this is the diamide, NH2 CONH2, diamide, urea. Actually, that is being substituted in the case of ammonia where one of the hydrogen is replaced by this, and this compound is said to be semi-carbazide. So all these derivatives, namely the hydroxylamine, hydrazine, phenylhydrazine and semi-carbazide, how are they going to react with aldehydes and ketones? We are going to write one by one, in which we can take the first example, CH3C double bond OH. The compound is acetaldehyde. When this is reacting with ammonia derivative called hydroxylamine, this is the formula for hydroxylamine. We know that it's an ammonia derivative, hydroxylamine. For the convenience, I can write this as HNHOH, where the nitrogen is containing the lone pair of electron. And usual steps are known for us. The nucleophile can attack the carbon. The nitrogen is going to attack this carbon atom. The nearby bond breaks up and oxygen can be added with this hydrogen. So the steps are well known for us. The first step will be attack of nucleophile. And second step is protonation of that oxygen. So at the end, we can have an addition compound. CH3, CH, it becomes OH. Here I can write NHOH. See this one, NHOH. Subsequently, it is to undergo condensation. While the condensation, what is happening? There is a chance of getting water molecule where the hydrogen is removed as a H+. The arrow mark denotes that the bonded electron pairing between the nitrogen and hydrogen is moving towards the carbon and nitrogen. There will be new bond initiation. Simultaneously, the nearby bond breaks up and OH is leaving as OH minus. So what will the product form here? It will be CH3CH, double bond NOH. The compound's name will be acetaldehyde. Oxime is the compound. So this is a product formed when acetaldehyde is reacting with the hydroxylamine. Likewise, if you take the acetone, the same idea, CH3C double bond O CH3, this is the molecule called acetone. All the reactions can be explained in a similar manner. When the acetone is in contact with the hydroxylamine, yes, the pair of electron is present on the nitrogen. So this can attack the carbon. The oxygen is bonded with the hydrogen. So the addition compound is formed as follows. We can have CH3, CCH3. It becomes OH. Here I can write NH and OH. The most similar manner what we were discussed earlier. The condensation is to take place. The hydrogen is removed, subsequently OH is leaving as OH minus. So after the removal of water, we can have a product CH3CCH3. It will be the double bond NOH. This is the compound CH3CCH3 double bond NOH. That was acetaldehyde oxide, but this is to be called acetone oxide is the compound. It clearly shows that when any aldehyde or ketone, including the aromatic aldehydes, are reacting with hydroxylamine, the products are oxides. You can have aldehyde oxide or ketone oxide. Is it clear? NH2. It is also an ammonia derivative. You must know the name of this compound. The compound is called as hydrazine. One of the ammonia derivative. How this is going to give the product with our aldehydes and ketones. I will be starting with the acetaldehyde as usually. CH3C double bond OH. The compound is acetaldehyde. Yes, when this acetaldehyde is reacting with the hydrazine, in which HNH-NH2. The hydrazine from which one of the hydrogen is taken out for the easy understanding purpose, the nitrogen can donate electron to this. It is attacking the nucleophile. This is providing electron to this hydrogen. Protonation takes place. Execute the change and find the product. This is the product which is expected here. CH3CH. CH3CH. It becomes OH. Here I can write NH2 for the convenience. You just see the NH-NH2. That is written here, NH-NH2. In the subsequent stage, that will be the removal of water. Condensation is to take place. The pair of electron is moving here in between the carbon and nitrogen. As a result of that, the hydrogen is leaving as H+. Usually, in most of the cases, hydrogen is leaving as H+. Subsequently, OH is removed as OH minus. H combines with OH. And the product will be CH3CH. And we can have the double bond NH2. After getting this product, we can have the name of the compound as acetaldehyde. Hydrazone is the compound now. Hydrazine is now converted into hydrazone. This is the final product which is expected. So we can try for the benzaldehyde, an aromatic aldehyde. It is a benzaldehyde. And if you take the benzaldehyde and the hydrazine, NH-NH2, a more similar case, attack of nucleophile on the carbon, the bond breaks up and the product is C6H5, CH, it becomes OH. Here I can write NH-NH2. In the next stage, there will be a chance of getting the water molecule. H is removed and OH is leaving. And the product will be C6H5CH double bond N, NH2. This is to be called benzaldehyde hydrazone. So hydrazines are becoming hydrazone when they are reacting with the aldehydes. It might be an aromatic aldehyde or aliphatic aldehyde. Here the aromatic aldehyde is benzaldehyde. Okay. Yes. Derivative. This is the ammonia derivative NH2 NHC6H5. The highlighted group is phenyl and hence the compound's name is phenylhydrazine. It is the compound. What happens when the phenylhydrazine is reacting with the aldehydes like acetaldehyde and benzaldehyde or with ketone like acetone? Here I have started with acetone instead of aldehyde. Anything can be selected, acetone is taken here. When the acetone is reacting with derivative called phenylhydrazine, one of the hydrogen is taken outside, NHC6H5. So in the NH2 part, one of the hydrogen is taken out. As usually, the nitrogen is going to attack this carbon and the bond breaks up, oxygen can provide electron to the hydrogen. Protonation. Execute the change and find a product. You can have CH3, CCH3. It becomes OH. Here I can write NH, NH, C6H5. Just see this. NH is there, NHC6H5. NHC6H5. During the condensation reaction, what is happening? The hydrogen is removed. As a H plus, subsequently OH is leaving as OH minus. So on the loss of water molecule, you can have a product as follows: CH3, CCH3. Double bond N, NH, C6H5. The compound's name will be acetone phenyl hydrazone. We were started with the hydrazine. Finally, the product is hydrazone. Yes, when you take the benzaldehyde, C6H5 CH double bond O, we will be getting benzaldehyde phenyl hydrazone. Formaldehyde can give formaldehyde phenyl hydrazone. But these kind of ketones, like aromatic ketones, diphenyl ketone, acetophenone, these type of ketones do not undergo the above given pattern of action because there are two bulkier groups which restricts the attack of nucleophile on the carbon, and due to other reasons, these two compounds, benzophenone, acetophenone, do not undergo this type of action because these two are having lesser reactivity on comparing with the formaldehyde, acetaldehyde and benzaldehyde. Okay. And the last derivative will be semi-carbazide. This is the derivative NH2NH C double bond O NH2. To recollect the molecular formula for this, just have an idea like this. NH3 ammonia and the urea, NH2 C double bond O NH2. Just fuse these two by replacing one of the hydrogen from the ammonia and by replacing one of the hydrogen from this urea. You can attach them so that you will be getting this product called semi-carbazide. Yes, this is going to be the molecular formula for semi-carbazide. How our aldehydes and ketones are reacting with the semi-carbazide? Here I will be selecting the acetone or acetaldehyde. Anything can be selected. Even the benzaldehyde can be written. Here I have started with acetaldehyde. The other reactions are taking place in the same mode, same manner in which reactions can be completed. And I will be writing the hydrogen NH, double bond O, NH2. This is the compound called semi-carbazide. The attack of nucleophile on the carbon, the oxygen gives electron to this hydrogen. Protonation takes place. Execute the change and find a product here. Here I can write CH3, CHOH. Here I will be writing it as NH. Just see this NH. And NH, it is going to be bonded with C double bond O NH2. This part is highlighted in the product side. After getting this, as usually, the condensation is to take place, the removal of water. The hydrogen is removed in the form of H plus and OH is leaving. And execute the change. We are expecting CH3, CH, double bond N, NH, C double bond O, NH2. This part is unaffected. The urea part of that semi-carbazide, it is kept as such. And the product is now obtained. The byproduct is H2O, but the compound's name is acetaldehyde semi-carbazone. The carbazide is now converted into carbazone. If you take benzaldehyde, you will be getting benzaldehyde semi-carbazone. Formaldehyde can give formaldehyde semi-carbazone. But acetophenone and benzophenone do not react with this semi-carbazide. So these are all the various actions of aldehydes and ketones with ammonia derivatives, namely phenylhydrazine, hydrazine, hydroxylamine and semi-carbazide. Is it clear? For the further updates and for the further conversions in the same reaction or in the same lesson, just continuously keep on watching our video classes. Thank you for watching.